Computer memory. How does the stack work? There are two types of memory. Allocation, that is stack memory, and heap memory. Programs in memory have the text segments where the code being executed is stored, the data segments with initialized and uninitialized global variables. Uh, there's also the heap and the stack. They grow towards each other. The stack sits higher in memory than the heap and grows towards lower addresses, whereas the heap sits lower than the stack and in general moves towards the higher addresses. Uh, this is the vague structure of a program in memory. This is all governed by the operating system. Let's see. We've got like the stack, it does some shit. Uh, Stack variables are vocal variables, so like the function that like makes them. Once that function returns, they get deallocated and overwritten oftentimes. There's the heap where you can keep your global variable. So if you put stuff on the heap, you can access it from like any function. And after that function returns, it can like do stuff with data structures. And then those data structures can persist after it's like dead and gone. Uh, oh, there's your mama. So with the heap, you have to like do it a little bit better than the stack. The stack is pretty automatic, but the heap, like, you have to be careful when you're like allocating it and freeing it because if you aren't careful, you'll get memory leaks, which happen when you forget to free a heap variable after you finish using it. And then for long running programs, like programs that execute for a long time, a lot of these like little fucking zombie variables can get created, and this will slow your program down and maybe even cause it to crash, which is unfortunate and bad. There is also the use after free thing, which is a common vulnerability in C and C++ programs. They show up in those languages because they don't have automatic garbage collection. I don't fucking know. But yeah, so use after free. It's like you free a heap variable, like you make one, you allocate one, you use it a bit, you free it because you think you're done with it, but you keep the pointer around. And then since you have it around, maybe you accidentally use it after you free it, but you've already overwritten that spot in the heap. So instead of getting like the data you expect to get, the values you expect to get, even the type of value you expect to get, you're getting a random value. And this value can cause undefined program behavior, and you might not like the results. And maybe if your application is fun and interesting, hackers will like the results.